Hi everyone! In this video we're going to do a few examples of three-part inequalities. This is one of the types of compound inequalities. The reason they have this name, three-part inequalities, well, because they have three parts. Look at this example. There is a part that's in the middle, and there is a number on each side. And we also can see two inequality symbols. First of all, I'd like to note that any three-part inequality is equivalent to this compound inequality. Notice that it's obtained by simply splitting up this three-part inequality into two separate inequalities. Well, if we keep the left and the middle parts together, that's going to be one inequality. And also if we keep together the middle and the right parts, that's going to be another inequality. They also have the word "and" in between them. We're going to talk about how to solve compound inequalities of this form in the next video. But the good news is that we don't really need to split up this three-part inequality in order to solve it. It's actually easier to solve it in this form. And this is how we approach it. Our main goal is to isolate the variable in the middle part. And the steps we take are very similar to if we only had a two-part inequality. Remember, we would start by subtracting 2 from both sides. Well, in this case, we don't have two parts, we have three parts. So when we say subtract 2, we're going to subtract it in the middle, on the right, and on the left. As the result, in the middle I'll have 5x, on the right hand side I'll have 15, and on the left I'll get -5. Next, if we were solving a two-part inequality, we would have to divide by 5 on the left and on the right. Well, we'll do that step, but we'll divide by 5 in the middle, on the right, and on the left. This will give me x in the middle, 3 on the right, and -1 on the left. And that's the solution to the given three-part inequality. Basically, it tells us that x values that satisfy the given inequality are between -1 and 3, including -1. When we solve inequalities, it's very common to express the solution using a graph and interval notation. Let's try that as well. Graphing the solution of a three-part inequality is very easy. We just said that x values that satisfy the given inequality are in between -1 and 3, and that's exactly what we need to highlight on the number line. First, I'm going to place values -1 and 3. Then I'm going to address the corresponding points. Since the inequality symbol that's right next to -1 is less than or equal to, I'm going to place the closed point at -1, and since the inequality symbol that's next to 3 is less than, I'm going to place an open point right next to 3. And then I highlight between these values. This is the solution expressed by the graph. And the graph is really helpful for writing down the interval notation. I just have to describe the highlighted interval by reading it from left to the right and saying where it starts and where it ends. The highlighted interval starts at -1, and since -1 is included, I use bracket next to it. I place comma and then put 3 with parentheses because 3 is not included. I have an open point here. So this is how we solve three-part inequalities, and that's how we can express the solution. Let's try another example. Here we have another three-part inequality. So our goal is to isolate x right in the middle. We start by subtracting 6 in the middle, on the right, and on the left. From there we get -2 in the middle, +8 on the right, and -6 on the left. To get rid of the coefficient in front of x, we need to divide by that coefficient. So I'll divide by -2 in the middle, on the right, and on the left. This will leave me just x right in the middle, -4 on the right, and +3 on the left. Well, notice that I haven't written the inequality symbols yet. Well, because I want to remind you what happens when we divide or multiply, in this case all three parts of the inequality, by a negative number. When such operation is performed, we have to reverse the inequality symbols. In other words, both inequality symbols become greater than. Try not to forget that step. And because we had to reverse the inequality symbols, our answer is written backwards. Notice how we have 3, greater number, on the left, and then -4, smaller number, on the right. So what we want to do before we graph this inequality is to rewrite this inequality backwards, placing -4 to the left and 3 to the right. And because I switched the order in which I am writing my inequality, I will have to switch the inequality symbols as well. So it's -4 less than x, and then less than 3. Now, even though my inequality looks different from the previous step, it actually tells exactly the same thing. If you compare, the inequality symbols are still pointing same way as they were pointing before. For example, here, the inequality symbol opens to x and points to -4. Well, it's exactly the same way here. So the meaning of this expression has not changed from the previous step, but now it's written in the correct form so that we can graph it. I place -4 and +3 on the number line. At both values, I'm placing open circles because they correspond to inequality symbols less than and indicate that neither -4 nor 3 are included in the interval. And then I highlight in between those values. So this is the solution to the given 3-part inequality expressed by the graph. And for the interval notation, I see that it's the interval that starts at -4 and ends at 3, from -4 to 3, with parentheses placed at both ends, because we are not including the endpoints. So this is how you solve the 3-part compound inequalities.